Hello all, let's start the part 3 of section 8.1, 8.2 and 8.3. In this part, I will talk about phase shift, correct? Phase shift. But I will talk about phase shift of graph of sine and cosine. I will just explain phase shift and graph of sine and cosine, but believe me, when I teach you tangent, cotangent, secant, and cosecant, I will not repeat this phase shift there because the phase shift for all of them, the procedure is the same. Now, I'll put some good notes here and I'll explain how you are dealing with the phase shift and what is the meaning of the phase shift. And after that, I'll explain this in two examples for you. Phase shift means a horizontal shift along x. It's a horizontal shift actually along x, correct? Now, few things. Remember this from algebra. Always we choose opposite sign. Opposite of sign. I will write everything. Later I'll explain everything. It means, remember when you had f of x minus h, correct? You were shifting opposite. Shift right, correct? Everyone thinks it goes left because it's minus h, but it goes opposite. And when you had f of x plus h, shift left, correct? Now, steps. Steps are important. Which steps you have to follow to can graph a given function. Step 1. Always do your vertical shift. And we already discussed how to do the vertical shift. Step number 2. Phase shift. I will not call it horizontal shift because we are in trigonometry. Usually we call it phase shift. What is important in phase shift, I'll put inside these parentheses with the red color, coefficient of x must be, even I put here double line under the must be 1. Remember. You will see it in an example what does it mean. The coefficient of x must be 1. Step 3. Period. You will find your period here at to phase. Step number 4. Key points. This is the 4th step that you follow and easily you can graph a phase shift. Let me explain all the steps in these examples. Example number 1. Graph y equal 3 sine of 2x minus pi. here, you see, like you have a phase shift, 2x minus pi. How you would deal with this? Step 1 is vertical shift, which we have none, correct? Because here we have plus 0 actually. It means we don't have vertical shift. Step 2 was phase shift. To phase shift, you must change the coefficient of x 1, which here in the given function, your coefficient of x is 2. Then how to change it to 1? Whatever the coefficient of x is, factor that one out, correct? Rewrite your function. It's really important. This step is really, really important. Rewrite y equals 3 sine, factor out 2. When you factor out 2, what left inside? 2x divided by 2 gives you x. Minus pi divided by 2 gives you pi over 2. Correct? And you are done here. Now, you see the coefficient of x becomes 1 immediately. I told you the coefficient of x must be 1. If it's a number, always factor that number, correct? This number that you see, negative pi over 2, this is actually your horizontal shift or phase shift. I'll show you two methods. My method, because I always remember the sign, if it's negative, it shifts right by pi over 2, correct? And if it's positive, it shifts left. But another method that some professors are doing, or maybe you saw it at high school or other classes, I want to show you that one. Don't say why he's doing this. The other method is your professors actually setting this parentheses equal to 0. X minus pi over 2 equals 0, and they solve it for x, which you add pi over 2 to both sides, correct, like this, and you end up with x equal pi over 2. It means you shift your graph by pi over 2 to the right, correct? But if you remember that just only this part, if it's x minus h, shift to the right. If it's x plus h, shift to the left, correct? Just remember this much. Now, I will stop working here and I'll try to start graphing a little bit because it's very important to show our shift, correct? One, two, three, 4, correct? I don't have a vertical shift. I have a horizontal shift by how much? By pi over 2. Pi over 2 is actually here, right? This is your pi over 2. What I do, I'll draw here a line. And this line for me means my new y-axis, correct? Because it's a horizontal shift. Now, next step is to find period. Step 3. P equals 2 pi over b. How much is your b? Your b is actually this number. This 2 is your b, right? The coefficient of x. It means 2 pi divided by 2, which gives you pi, correct? Now, because with the phase shift, because we are moving from 0 to pi over 2 and we start graphing from pi over 2, we need to do a little bit more work with our period to find the actual period. Whatever this period is, correct? Add this period to your phase shift. You see your phase shift is pi over 2. We add pi over 2 with this and it gives us the end of the period. Where is actually the end of our period, which gives us 3 pi over what? 3 pi over 2. I'm not going to show you how to add these two numbers. You already know. I did in few examples. When you add these two, it gives you 3 pi over 2. And I'll mark here as a 3 pi over 2. This is your 3 pi over 2. Now, you need to find the center of your graph. It means this point. How much is this? Then the quarters, which will be here and here. This is the full period. You need to find first the center, which is this point, the red, and the quarters, which I'll mark it with green, here and here. How to find the center? Because you have this shift, you need to do a little bit of work, not that much, very beginner work. Find the average between pi over 2 and 3 pi over 2, then divide by 2, right? Finding the center of two numbers, actually we are doing average. What I do, I'll add pi over 2 with 3 pi over 2, correct? Which gives me 4 pi over 2, which I can reduce it to 2 pi, correct? Then I will divide it by 2, correct? Which gives me what? Pi. It means my center here will be pi. Also, when you want to find the first quarter, average this two number, pi over 2, add it with pi, which gives you 3 pi over 2, and divide by 2, it means multiply it by 1/2, which gives you 3 pi over 4. Correct? It means this green point will be 3 pi over 4. And also to find the third quarter, you can average pi with 3 pi over 2, pi plus 3 pi over 2, which gives you 5 pi over 2, and divide by 2, which gives you 5 pi over 4, correct? Now you are done with your period. Exactly where is the period, where is the beginning of the graph, where is the end of the graph, where is the center, and where are the quarters. You marked all of them. The next step is to actually find the step number 3, 4 key points, and also which graph you are dealing, where are the zeros. We are dealing with sine. With the sine, we know our zeros are at the endpoints. It means here, center, and also end, which is 3 pi over 2. Key points for this graph will be the quarters. The first quarter, which is 3 pi over 4. Usually, with the standard graph of sine, it's 3 pi over 4 and 1. The first one is positive. And in the third quarter, it will be 5 pi over 4 and negative 1. But you need to find the new key points. Remember, you always multiply it with your amplitude, with A, which is 3, correct? It means you multiply here your output with 3, and you multiply here your output with 3, gives you the new key points, which is 3 pi over 4, comma 3, and 5 pi over 4, comma negative 3. Please find these points in your graph. 1, 2, 3. Here is 3. 1, 2, and here is negative 3. You have 3 pi over 4 and 3. 3 pi over 4 and 3 is this point. 5.5 pi over 4 and negative 3 is here. Now, the graph of sine always starts from here, 0. It goes up, crosses the pi at 0, goes down to 5 pi over 4, and goes up back to 3 pi over 2. You graphed only one cycle, correct? You graphed only one cycle. If you add pi, k pi in it, you can also graph more cycles here, correct? This is how you graph the phase shift. It's not that difficult. The procedure is you have to first change the coefficient of x to 1. It means factor the number. Then find your period. After you find your period, add the phase in it. Then find the key points. And after that, mark your zeros. Change your key points to actual one and graph. Let me explain something here for you with the blue color. This number, which I called it amplitude is actually a vertical stretch or compress. Correct? You saw it before. This b, which is the coefficient of x, is actually horizontal stretch or compress. This pi over 2 is your horizontal shift. And if you have a number here outside, it can be your vertical shift. When we do actually transformation, we can go up to 5 transformation. Here you have 3 of them. If I had a vertical shift also, it will be 4 transformation. If I had a negative at the beginning, it will be the reflection. It will be the 5th one. You can have up to 5 transformation in one function, which we had in this example 3 of them. Please, when you learn everything, not just graphing. You should know the meaning. Amplitude is a vertical stretch or compress. The coefficient of x, which is b, is your horizontal stretch or compress. Here, the number inside the parentheses, this is your phase shift. And the number outside, if you have, that will be a vertical shift. Correct? I will do one more example for you. And when you learn it with sine and cosine, it's same for tangent, cotangent, secant, cosecant, all of them. You need to just apply your transformation, and you should know the meaning. Example number 2. We will graph this time y equal 2 cosine of 4x plus 3 pi. And outside plus 1. First, you need to change the coefficient of x to 1. Rewrite your function. Y equals 2 cosine bracket, factor out 4. Inside will be x plus 3 pi over 4. Close the bracket, plus 1 outside. Now your coefficient of x is 1. You're good to go. Start the steps. Step number 1, vertical shift. I have here a vertical shift, as you see. Up 1, right? Start slowly graphing. Put everything together. Actually, I have to move this line. here. I will explain why I moved it. This is X, this is Y. Let's start with your vertical shift, up 1. If this is 1, draw somehow the new axis. You don't need to, but it's good because you want to find your points on it. It's good to have your new x-axis. You are done with vertical shift. Step number 2, you are dealing with horizontal shift, correct? How much is your horizontal shift? Look at only this number. Positive 3 pi over 4. Opposite sign. It means you shift left by negative 3 pi over 4. Correct? If I mark here, negative 3 pi over 4 is here. I will draw here my horizontal shift. Now you need to find the period, correct? You are done with your horizontal shift, vertical shift. You need to find in step 3 your period, which is P equals 2 pi over this number B over 4, which gives you pi over 2. And you need to add this to your horizontal shift. It means pi over 2 minus 3 pi over 4, whatever that is, it's your end of the period. Let's calculate. You multiply the first fraction by 2 to get the common denominator. 2 pi minus 3 pi gives you pi, negative pi, right? Over what? 4. Correct? This is negative pi over 4. Now, to find the middle, you average. I'm not going to show it again for you. When you average this, it gives you negative pi over 2. To find the quarters, you average negative pi over 4 and negative pi over 2, which gives you negative 5 pi over 8. And also here in this quarter, it gives you negative 3 pi over 8. This is the old x-axis. Move your points on the new one. Here, 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 and here. Now, look at your amplitude. Your amplitude is 2, correct? You are moving from new x-axis 2 units up and 2 units down, which you go to negative 1. Correct? Now, you are dealing with graph of cosine. When you are dealing with graph of cosine, the cosine starts from here. It peaks at the end, and it peaks at the center, and it peaks at the beginning, correct? If you go 2 units down, it means your graph starts from this point. And at quarters, there are key points. At quarters, you have zeros. Here, you have 1 0 here, then this quarter, and you have another 0 in the third quarter. Correct? At pi over 2, you go to negative 1. Correct? And if you want to graph it now with green, where? Oh, sorry, I went wrong. I moved wrong. Points are really tight and close here. You have to be careful. It goes to 0, and from here at pi over 4, it goes back here. It's one cycle of the graph. Of course, if you continue, you can go this side, you can go this side. just add your k pi in it. It gives you the rest if you want to draw few cycles or few periods. Correct? This is how you do apply your horizontal shift. Correct? I'll show you one more example with negative. Then I'll stop the lecture and we are done with sine and cosine, and immediately we start with tangent. I will just explain to you the graph of tangent, the shape, also the secant and cosecant, but I will not do any transformation there. It's your job to do because I explained everything on sine and cosine. Example number 3. Y equals -3 sine of, let's say negative 2x plus pi over 2. I will not put a vertical shift for you here, just horizontal shift. I don't want to make it too difficult. First of all, the coefficient of x should be always positive 1, correct? Then I'll factor out -2. Be careful when you are factoring. Y equals 3 sine of -2. When you factor -2 pi divided by -2 gives you, sorry, it's x, not pi, gives you x. Positive pi over 2 divided by -2 gives you negative pi over 4. Here. Now, still this negative is a problem, correct? We need to change to positive. Remember, the graph of sine is an odd function. It means f of negative x equals the negative f of x. It means you can bring this negative to the beginning of this, correct? And you have another negative there also. It means your graph becomes, your function becomes like this. -3. I will show you. Like this. Then sine of 2 parentheses x minus pi over 4. Correct? -3 gives you positive 3. Y equals 3 sine of 2 parentheses x minus pi over 4. And that's the actual function that you want to graph. Please, you are not factoring -2. This is the reason you are dealing with the odd function. Sine is an odd function. Correct? Now, I don't have vertical shift. I'll start with my second step, which I have a horizontal shift or phase shift. Correct? Negative pi over 4, it means you are shifting to the right by pi over 4. Here is your pi over 4. Here is pi over 4. Now you need to find the end of your period. To find the end of your period, p equals 2 pi over 2, which gives you pi, and you are adding this phase shift in it, another pi over 4, which gives you 5 pi over what? 4. It means this point is 5 pi over 4. Again, when you average, 3 pi over 4 will be the center, correct? Pi over 2 will be the first quarter, and pi will be the third quarter. Now, find your zeros. You are dealing with the sine. You have a 0 at the beginning. You have a 0 in the middle or center, and you have another 0 at the end. Key points. The key points for graph of sine is 2 key points. The first quarter, which is pi over 2, comma 1, positive, and the third quarter, which is pi and -1, but you need to change this to number, right? Based on a, you multiply a in it. It means times 3 times 3, the output, correct? The new key points will be pi over 2, comma 3, and pi, comma -3. Mark those, correct? 1, 2, 3. Here is 3. 1, 2, -3 is here. Now, at pi over 2, it becomes 3. Pi over 2 becomes 3. At pi, it becomes -3. Only you need to connect these points with a smooth curve. It's the easiest way to graph these trigonometric functions. Believe me, I'll show you the easiest way. How many shifts we have? Here, look, in this problem, you have a horizontal shift. You have, how many transformation we have? You have a horizontal stretch, and you have also a vertical one. Correct? This is how we are dealing with our function. And you may ask me, how much is then the period from here to 5 pi over 4? How much is your period? You see, it's actually pi. Okay. One period is pi. Correct? We are done with section 8.1, 8.2, 8.3. Actually, I gave you more in your book. They don't do vertical shift. I show also the vertical shift for you. I'll stop the lecture here and see you all in section 8.4, maybe 8.5 together. I will graph tangent and cotangent, and I'll show you how to graph secant and cosecant.